Now we're in chapter 7.1 and we're going to be looking at rational expressions and their simplification. Objective 1, we're going to find numbers for which a rational expression is undefined. A rational expression is the quotient of two polynomials. Here are some examples of rational expressions. X plus 3 all divided by x squared plus 2x, 5 over x minus 2, and x over 7. These are rational expressions because the expression in the numerator is a polynomial and the expression in the denominator is also a polynomial. Now, rational expressions are undefined at any value that produces a denominator of 0. So undefined is when your denominator is 0. These are the steps for determining the numbers for which a rational expression is undefined. Step 1, set the denominator equal to 0. Step 2, solve for the variable, and you may have to factor if necessary. Let's go in our books to page 497, and let's look at problems 6, 10, 16, and 20. The instructions say, find all numbers for which each rational expression is undefined. If the rational expression is defined for all real numbers, so state it. And for number 6, we have 17 divided by 6x minus 30. So we're trying to find all the values of x for which this rational expression is undefined. So step 1, you're going to set the denominator equal to 0. So we have 6x minus 30 equals 0. And then step 2, we're going to solve for x. So in this case, we can just add 30 to both sides. And we'll get 6x equals 30. And then we can divide by 6, and we end up with x equals 5. So when x is 5, if you plug it back into your expression, you'll end up with a 0 in your denominator. Therefore, it is undefined. Let's try number 10. And we have 8x all divided by, and then we have 4x minus 19 times x plus 2. So we're going to start with step 1, which is to set your denominator equal to 0. So we're going to have 4x minus 19 times x plus 2 equals 0. Now we get to solve for x. Remember the zero product principle. You're going to take each one of these groups, so 4x minus 19, and set them equal to 0, and x plus 2 equals 0. So this one will tell you that when x is negative 2, your expression is undefined. And solve this equation, and you'll end up when x is 19 over 4, the expression is undefined. All right, let's try number 16. And we have y plus 8 divided by 6y squared minus y minus 2. And again, we're finding the values of the variable that make the expression undefined. So we're going to start by setting the denominator equal to 0. So we have 6y squared minus y minus 2 equals 0. And then step 2 is to solve for the variable, but in this case we have to factor first. So remember how you factor this kind of polynomial. You're going to start by finding the product and the sum. So the product is 6 times negative 2, which is negative 12. And the sum is the middle term, or the middle coefficient, which is negative 1. So now you want all the factors of negative 12 that will add and give you negative 1. And those factors are negative 4, and positive 3. We can check it because negative 4 times 3 is negative 12, and negative 4 plus 3 is negative 1. Then you took these factors and you replace the middle term. So your polynomial is going to become 6y squared minus 4y plus 3y minus 2. So 6y squared minus 4y plus 3y minus 2 equals 0. And then you end up with an expression with 4 terms, so you know you're going to factor by grouping. So group the first two together and group the last two together. Always add between your two groups. And then you're going to take the GCF out of each group. So for the first one, it is 2y. We factor it out, and we're left with 3y minus 2. And in the second group, they do not have a GCF, so we're just going to write it as plus 1. And then we still have 3y minus 2. Of course, this still equals 0. Now remember that once you have your groups the same, you factor it out. So we have our 3y minus 2. And it's like they cancel each other out, or they're canceled out. And then what's left over? The 2y plus 1. This equals 0. So now you end up with an expression just like you had in number 10. So you take each one of your groups and you set it equal to 0. So now we're going to have 3y minus 2 equals 0, as well as 2y plus 1 equals 0. Solve for y in both, and for the first one you get y equals 2 over 3. And then for the second you get y equals negative a half. So when y is 2/3, or when y is negative a half, this expression is undefined. Now let's look at number 20. And we have 8 over x squared plus 4. And again, we're looking for the value of x that make this expression undefined. So we're going to start by setting the denominator equal to 0. And we have x squared plus 4 equals 0. Now we need to solve for x, so we're going to need to factor. However, this cannot be factored. It's actually prime. So let's go ahead and write prime, meaning not able to be factored. Therefore, this expression is defined for all real numbers. So you will write your answer as defined for all real numbers. Alright, objective 2 is now simplifying rational expressions. Here are the steps for simplifying rational expressions. Step 1, we're going to factor the numerator and the denominator completely. Step 2, cancel any common factors in the numerator and the denominator. So let's go in our books to page 497, and let's start by looking at number 29. The instructions say simplify each rational expression. If the rational expression cannot be simplified, so state it. And for number 29, we have negative 15 all over 3x minus 9. And we're simplifying, so the first thing we want to do is factor the numerator and the denominator. The numerator is just a number, so we're going to leave it alone as negative 15. And the denominator, we're going to factor out the GCF, which is 3. So remember, you write 3, and then you open up your parentheses, and you have x minus 3 left over on the inside. Now we can simplify the 3 and the negative 15. 3 goes into 15 5 times, so the 3 will become 1. And the negative 15 is now negative 5. So your final answer is negative 5 over x minus 3. You know you reach your final answer when there's no other factors that can be canceled in the numerator and the denominator. Now number 33. And we have x plus 5 divided by x squared minus 25. So again, let's start with step 1, which is to factor the numerator and the denominator. The numerator is factored already, so that's x plus 5. The denominator can be factored, x squared minus 25. Remember, this is the difference of squares. So it's like it can be factored into x minus 5 and x plus 5. Now we cancel any common factors. So x plus 5 and x plus 5 cancel out, leaves a 1, and cancels out and leaves a 1. So the final answer is going to be 1 divided by x minus 5. Let's keep going. Let's look at number 42. And we have y squared plus 5y plus 4 divided by y squared minus 4y minus 5 and let's start by factoring the numerator and the denominator. So these are both product and sum. The leading coefficients are 1 and 1. So let's start by factoring the first. So we have y squared plus 5y plus 4. The product is 1 times 4, which is 4. And the sum is 5. So now you want the factors of 4 that will add and give you 5. And they are 1 and 4. So the top will factor into y plus 1 times y plus 4. And then for the bottom, we have y squared minus 4y minus 5. And the product is 1 times negative 5, which is negative 5. And the sum is negative 4. So now you want the factors of negative 5 that will add and give you negative 4. And they are negative 5 and positive 1. So the denominator factors into y minus 5 times y plus 1. Now we cancel any common factors. So y plus 1 cancels with y plus 1. And our final answer will become y plus 4, all divided by y minus 5. Let's look at number 49. And we have x to the third power minus 2x squared plus x minus 2, all divided by x minus 2. So x to the third minus 2x squared plus x minus 2, all divided by x minus 2. Let's start by factoring the numerator and the denominator. So the numerator is x to the third minus 2x squared plus x minus 2. There are 4 terms, so we're going to factor by grouping. So group the first 2 terms together, group the last 2 terms together. Always add between your 2 groups, and then take the GCFs out of each group. So for the first one, the GCF is x squared, and we're left with x minus 2. And for the second, the GCF is just 1 because these 2 terms have nothing in common. So we'll write 1 on the outside and then write the x minus 2. Now the groups or the parentheses are the same, so let's factor it out. So we have x minus 2, and we're left with x squared plus 1. So this becomes x minus 2 times x squared plus 1. and then the bottom stays x minus 2. Now we cancel any common factors, so the x minus 2's cancel out, and the final answer is written as x squared plus 1. All right, number 76. And we have x squared plus 3xy minus 10y squared. All divided by 3x squared minus 7xy plus 2y squared. We want to factor the numerator and the denominator. Let's start with the numerator, and we have x squared plus 3xy minus 10y squared. The product is 1 times negative 10, which is negative 10, and the sum is 3. So now you want the factors of negative 10 that'll add and give you 3, and they are 5 and negative 2. 5 times negative 2 gives us negative 10, and then 5 plus negative 2 gives us positive 3. Now because the leading coefficient is 1, we can just go ahead and write our factors as x plus 5y and x minus 2y. Now we get to factor the denominator, and we have 3x squared minus 7xy plus 2y squared. Now the product is 3 times 2, which is 6, and the sum is negative 7. So now you want the factors of 6 that will add and give you negative 7, and they are negative 1 and negative 6. Because the leading coefficient is not 1, this time you're going to take your factors and replace the middle term. So our polynomial is going to become 3x squared minus xy, because of the 1, minus 6xy plus 2y squared. Now we have 4 terms, so we factor by grouping. Group the first 2 terms together, and then group the last 2 terms together. Always add between your 2 groups. Now take the GCFs out of each group, and for the first it's going to be x, and we're going to have 3x minus y remaining. And then for the second is going to be negative 2y, and we'll have 3x minus y remaining. Now our groups are the same, so let's factor them out. So we have 3x minus y, and then we'll be left over with x minus 2y. So the denominator becomes 3x minus y, and then x minus 2y. And we factor any common factors out, or we cancel any common factors out. So x minus 2 cancels with x minus 2. And the final answer is x plus 5y, all divided by 3x minus y. So now we can simplify rational expressions with opposite factors in the numerator and the denominator. So the quotient of 2 polynomials that have opposite signs and are additive inverses is negative 1. In their example, they have a minus b, all divided by b minus a. Notice that our factors are the same, so we both the numerator and the denominator have an a. they also have a b. Now the a in the numerator is positive and the a in the denominator is negative. The b in the numerator is negative and the b in the denominator is positive. Therefore, they have opposite signs. And if we were to add these expressions together, we would get 0. That's what makes them additive inverses. So when you go to simplify them, they actually cancel each other out. But instead of being left with a positive 1, we're left with a negative 1. Let's look at a couple examples. So in our books on page 497, let's look at number 60. And again, we are simplifying the rational expressions. And we have x minus 7 over 7 minus x. So x minus 7 over 7 minus x. Notice that we have the same terms. We both the numerator and the denominator have an x as well as a 7. However, the x in the numerator is positive and the one in the denominator is negative. The 7 in the numerator is negative and the one in the denominator is positive. Therefore, the numerator and the denominator are opposite, so they cancel each other out. But instead of being left with a positive 1, we're left with a negative 1. So the final answer would be negative 1. All right, let's move on to number 63. And now we have x minus 5 divided by x plus 5. And of course, we want to simplify. So even though we have an x in the numerator and an x in the denominator, they are not opposite of each other. Therefore, we cannot cancel them like we did in number 60. Both terms have to be opposite. So the 5, so I have a negative 5 in the numerator and a 5 in the denominator. They are opposite. However, x minus 5 is not opposite from x plus 5. So we cannot simplify these. We can't factor them, and they do not have any common factors. Therefore, we will write our answer as cannot be simplified. Okay, this will conclude our video for Chapter 7.1. Please email me if you have any questions.